Before the starting, if you want to skip the intro and head straight over the tutorial, I suggest you skip all the way to step 1 using the timestamps. Thanks. Many people think the only way to improve PC performance is by upgrading hardware. But what if you could make 8GB RAM perform like 16GB without buying anything? Windows often wastes memory on background apps, unnecessary services, visual effects, and poor memory management. In this guide, I will show you practical system optimizations that dramatically reduce RAM usage and improve multitasking performance. These tweaks work for Windows 10 and Windows 11 and are completely safe when applied correctly. Let's begin. Step 1. Understanding RAM usage. Before optimizing, it's important to understand how Windows uses RAM. RAM stores temporary data for active programs. When RAM becomes full, Windows starts using virtual memory, which relies on your storage drive. This is much slower than RAM. That's why systems with limited RAM start to feel sluggish when multiple applications are open. Our goal is to reduce unnecessary RAM usage and optimize memory allocation. Step 2. Check current RAM usage. First, check how much RAM your system is currently using. Press Ctrl plus Shift plus Escape to open Task Manager. Click the Performance tab, then select Memory. Here you can see total RAM installed, current RAM usage, cached memory, and memory compression. If your system is using over 70 to 80% RAM while being idle, optimization will significantly improve performance. Step 3. Disable startup programs. Many applications start automatically when Windows boots. These programs consume RAM even when not in use. Head over to the Startup tab in Task Manager. Look for applications with high startup impact. Examples include Discord, Steam, Spotify, Adobe services, game launchers. Right-click and select Disable, or simply click on the Disable option above for anything you don't need at startup. This reduces RAM usage immediately after boot. Step 4. Disable background apps. Windows allows apps to run in the background even when closed. These apps continuously consume memory. Open Settings, navigate to Apps, Installed Apps. Then scroll all the way down to System Components. Select unnecessary apps and disable their background permissions in their advanced options. You can also terminate their process immediately by scrolling down through the Terminate option to reduce memory consumption significantly. Step 5. Disable visual effects. Windows visual animations look nice, but consume RAM and GPU resources. Press Windows key. Search Advanced System Settings. Under Performance, click Settings. Choose Adjust for Best Performance. This disables animations like window fading, menu animations, shadow effects. Your system will feel noticeably faster by disabling them. Step 6. Optimize virtual memory. Virtual memory acts as backup RAM using your storage drive. Optimizing it improves stability on low RAM systems. Open Advanced System Settings again. Go to Performance Advanced Virtual Memory. Uncheck Automatically Manage Paging File Size. Set a custom value. Make sure your initial size is 1.5 times your RAM and maximum size is 3 times your RAM. Click Set and restart your PC. Step 7. Disable unnecessary services. Several Windows services consume memory unnecessarily. Open services.msc. Consider disabling services like sysmain, Xbox services, downloaded maps manager, fax, phone service. This reduces background RAM usage. If you want to learn more about services and what do they do, check out my video I've made entirely on services. Step 8. Browser RAM optimization. Web browsers are the biggest RAM consumers today. If you are a Chrome user, head over to Settings, performance and enable the memory saver. The same mode goes for Microsoft Edge by the name Sleeping Tabs. Step 9. Enable hardware acceleration. Hardware acceleration allows the GPU to handle certain workloads. This reduces RAM and CPU usage. Enable this in browsers, video editors, and productivity apps. Step 10. Remove RAM-heavy apps. Some programs are extremely memory-intensive. For example, Chrome with many extensions, Electron apps, heavy launchers. Consider lighter alternatives where possible. Step 11. Memory compression. Windows includes a feature called memory compression. This compresses inactive memory pages to reduce RAM usage. Most systems already have this enabled automatically. It allows Windows to store more information in available memory. To check if you have memory compression enabled or not, simply open your Task Manager and head over to the Memory tab. There you'll find out memory compression. Check if it has any memory compressed already. If not, head over to PowerShell and open it with administrative rights, and type the following commands. Get mmagent. This will tell whether or not your system has memory compression enabled. Type enable mmagent - memory compression to enable the feature. To disable, type disable mmagent - memory compression to disable the feature. Step 12. Advanced Registry tweaks. Advanced users can adjust system responsiveness through registry settings. Press Windows key plus R, type regedit, navigate to System, Current Control Set, Control Session Manager, Memory Management. Tweaks like memory priority adjustments can help optimize performance. Always create a backup before editing registry values. Let's start by understanding what each value functions, and then we will tweak it. Value 1 Clear Page File. At shutdown page file is the reserved memory on hard drive used as an extension of RAM. This memory contains data that was not recently used by RAM and transferred to hard disk. It may constitute of the information stored by third-party applications. Along with certain personal data, it may include the data like usernames, passwords, credit card numbers, and other security PINs. Page file can be cleared on shutdown, manually, as Windows does not do so. To clear page file at shutdown, double-click this value to modify. In the Value Data field, change the value from 0 to 1. Click OK to save your changes. Value 2. Disable Paging Executive. Disable Paging Executive permitted systems load kernel directly to the RAM rather than virtual memory, which is comparatively slower. Disable Paging Executive, when enabled, is also helpful in debugging drivers. A 64-bit Windows may have this feature enabled by default. 32-bit users can manually enable it by double-click this value to Modify. In the Value Data field, change the value from 0 to 1. Click OK to save your changes. Value 3. Large System Cache. An activated large system cache increases the size of system cache. It usually heightens the system performance but lessens the physical memory space for other applications and services. Double-click this value to modify. Change the base from hexadecimal to decimal. In the file next to Value Data, replace 0 with 192, making it 192 megabytes. Click OK to save your changes. Value 4. Non-paged pool size / paged pool size. Paged pool is a portion of memory that stores the pages with intention to move them to the page file, while non-paged pool is a contrariwise concept that stores the pages but never moves them to page file. Enabling both the values require postulating the exact size in bytes. It is suitable to disable these values to put the system in charge of calculating prime value, which adjusts dynamically. The value for paged pool size may range between 1 megabyte to 512 megabytes. However, it is recommended to set 192 megabytes. Double-click this value to Modify. Change the base from hexadecimal to decimal. In the file next to value data, replace 0 with 192, making it 192 megabytes. Click OK to save your changes.
Value 5, non-paged pool quota / paged pool quota.
By enabling these values, you are aimed at limiting the memory resources to each single process. If in case the process tries to exceed the allocated quota, it would fail. Therefore, it is recommended to leave it disabled or disable it if enabled. Both the values are enabled by specifying the size of memory allocated to non-paged pool and paged pool, respectively. This size ranges between 1 megabyte and 128 megabytes and is assigned through value data. On the other hand, disabling these values authorize the system to calculate an optimal value for both the entries based on current physical memory and auto-adjusts in case of change in memory size. To disable these values, double-click this value to modify. Make sure the value data is 0 to make it auto-managed by system. Click OK to save your changes. Value 6, Physical Address Extension. Physical Address Extension, generally known as PAE, is the technology that enables 32-bit operating system to access more than 4 gigabytes memory, up to 64 gigabytes or 128 gigabytes, depending on the physical address size of processor. A 64-bit system has the ability to access more than 4 gigabytes RAM and does not necessitate PAE. If you have a 32-bit Windows with sufficient RAM, you need to enable this value in the Registry editor. Double-click this value to modify. In the Value Data field, change the value from 0 to 1. Click OK to save your changes. Value 7, Session Pool Size. The registry entry noted above deals with the memory used for the allocation of video drivers. If the size of session pool is predefined, it limits the active session from using excessive memory, and if it does, the session crashes with a stop message. To avoid such inconvenience, you are suggested to elevate the value of session pool size. Double-click this value to modify change the base from hexadecimal to decimal. In the Value Data field, change the value to 48. Making it 48 megabytes. Click OK to save your change.
Value 8, Session View Size.
Session view size is the key that is related to the desktop heaps within the active session on a server or workstation. It allocates to memory to Interactive Window Station. Interactive Window Station contains group of desktop objects like windows and menus. It has the attitude similar to session pool size, as it freezes the process when trying to access the allocated memory. Double-click this value to modify. Change the base from hexadecimal to decimal. In the Value Data field, change the value to 96, making it 96 megabytes. Click OK to save your changes. Value 9, System Pages. System pages refer to the number of page table entries, PTE, reserved to store the mapping between virtual addresses and physical addresses. This mapping is performed by dividing RAM into fixed-sized page frames. Information is stored and mapped in these page frames. If value of system pages has to be other than 0, it must be allocated with the maximum value. However, it is recommended to leave it system managed, as system adjusts and calculates the optimum value for this entry if the value data is left 0. Double-click this value to modify. In the value data, make sure the text field indicates 0. Click OK to save your changes. After applying these optimizations, many systems experience lower idle RAM usage, faster application loading, better multitasking performance, reduced system lag. Your PC may feel significantly more responsive. Even without upgrading hardware, proper system optimization can dramatically improve performance. If this guide helped you improve your system, make sure to like and subscribe, and check out the rest of my Windows optimization tutorials. Thanks for watching, and I'll see you in the next guide.